Good morning, good morning, good morning. I am very sorry that I'm not able to be in today. That is going to be because I still have ice on my roads. I'm kind of a little bit farther north than you guys. Haven't had a chance to have any de-icing come through, so unfortunately, I'm still homebound. Now, that doesn't mean we can't do work though, and we're going to start something that is kind of new, kind of something we've already done, right? So what we're doing is we are still finding surface area of these different shapes, but they're word problems now. I know, word problems, blech. But, all right, but you guys can do this. Promise. It's not as bad as it sounds. If you can find the surface area of these, you can find these word problems. First step is going to be to read the question and identify whatever surfaces you need to solve for the area of. A lot of these you don't have to solve for every surface area. A lot of them you can cut off one or two of them depending on what the question's asking for. Like this first one. See, I've asked it in a way to where you don't have to have the total surface area. Okay? Draw the surfaces you need to solve for the area of and include their lengths. This is going to be where we break it down into its basic pieces, just like we always have been this year, okay? Solve for the area of each of the surfaces that you've drawn, and then add the appropriate surfaces together. Let's try, okay? Let's try, and I'll show you how easy it can be, right? So first and foremost, I'm reading this. Mr. Ring is painting a room in his house. The image below represents the size of his room. He wants to paint each of the walls and the roof, the ceiling, the same color. Find the area that he needs to paint. Now, first and foremost, when I'm looking at this, I'm saying, okay, he needs to paint not the entire room, because that room may have carpet on the floor, may have tile on the floor. And even then, it says walls and roof, nothing else. So let's take a look at some of the wall ideas that we've got here. I've got this wall that is in front and this wall that is in back. Okay? If I wanted to find the area of those rectangles, I've got a length across the bottom, and that is going to be 20 because that's this line here. And I've got a height here, and that's this height here, which is 10. To find the area of this rectangle, all I have to do is multiply those two. 20 times 10 is 200. Notice I have two of them. That means that between these two, I have 400 square feet that I'm looking to find the area of, or that I'm looking to paint. From here, I've got my side-to-side walls. You know, the left one over here, as well as the right one over here. Okay? If I look at those, I know, okay, on those, I'm going to have 30 because of that length there. And the height, well, this is still going to be 10 because it doesn't matter which side we're with. Those walls are going to be the same height. 30 times 10 is 300. So between the two of those, 600. Okay, so up to 1,000 square feet. How to get 1,000? 400 and 600. Don't forget, though, I want to paint the roof the same color. And that's this top part up here. All right? If I look at this room and I want to find out how long and how wide the roof is, I'm looking at this line here, the 30, and this line here, the 20. The roof of 20 by 30 makes 600. I am asking you now, do I have to multiply that 600 by 2? In this case, no. And the reason for that is because, again, I'm not painting the floor. I'm painting all four walls. I have 200 front, 200 back, 600 left, 600 right. Add those, 1,000. Plus 600 for one ceiling gives me a grand total of 1,200 feet squared. And that is going to be the answer here. In this case, I did not include the floor because I will not paint it. When I go to the next example that I'm looking at here, It talks about top hats making cylindrical boxes to store their hats in when they are not in use. They're made out of cardboard and close around the hat on all sides. An example of the boxes is below. What is the surface area of the box? Now notice, when it says something straightforward like all sides, that means I'm looking at everything. Because again, we're talking about making a box for a hat, and we want to have the hat be able to be carried in that box, transported in that box, stored in that box. It's got to have a top so that things can be put on top of it. It's got to have a bottom so that it doesn't fall out. It's got to have walls on all the sides to support the lid. Like, you get the idea, okay? Speaking of lids, we're assuming no overlap here. I know that's not a real world example because you're going to have a little bit of overlap, but unless it tells you about that overlap, you don't gotta worry about it, right? So let's go ahead and take a look here. What is the surface area of that box? Okay, so once again, we want to talk about what we have to work with. We have a bottom and we have a top, and they're both circles. To find the area of these circles, it is going to be pi r squared. Okay? All right. So I'm going to go ahead and pull up a calculator real quick so that I can do that with you guys just now. For that calculator, again, we're going to be looking for pi r squared. Pi, the radius on that, come on, I'm pushing it, pi, times 6 raised to that 2. Pi 6 squared equals 113.1. Good enough for me. 113.1. Times 2, because we got a top and a bottom for that, turns into 226.2. That takes care of ceiling, top. That takes care of floor. Now we want to talk about the rectangle that wraps around. Now I know it's 10 tall, but I have to be able to solve for that length there. That length wraps around that circle, and there's a word for things to go around a circle. It is circumference, and you guys, you should know the formula for that by now. It is 2 times pi times the radius. 2 pi 6. You punch that into the calculator, you get 37.7. That 37.7 is the length of that rectangle. I take that 37.7 and I multiply it by the height of 10 that you guys got there. All right? And that is going to be 377. And since there's only one rectangle wrapped around the outside, I don't have to worry about multiplying it by anything else. I add those together, 377 plus 226.2, and that equals 603.2. And that is going to be my real world example. Again, you just have to look at the question and say, 1, what is the picture that they're giving me? And what of it do I have to find the area of? 2, draw each of the pieces with the lengths that correspond to each part of that piece and find the area of each of those individual parts of that shape. 3, add together the areas that matter. If you don't need to paint the floor, don't paint the floor. If your box does not have a lid, you're not including the lid, okay? From there, you have your answer. I'd like you to go ahead and begin working on your worksheet. You may work in your pairs, but I should not have groups connecting together, okay? Thank you.